So in a sense, let's continue the talk. We don't have to completely switch the gear to the different direction. But to start with, as we did in the last panel, I would like to invite everyone to talk about yourself and your company and some accomplishments in the past 1 year. If you could start with yourself. Yeah.
Excellent. Good afternoon, everyone. My name is Mack Koepke. I'm the SVP for Business Development at Loft Orbital. Loft is a company that makes space simple. So we've created an abstraction layer, both hardware and software, and the idea is that we remove the complexity for our customers in delivering their missions to space. So you don't have to worry about integration, you don't have to worry about operations, launch, licensing, et cetera, Those are all things that Loft takes care of for you. Lots of exciting things in the past year. In January of this year, we actually closed a Series C round, raised about $170 million, which is funding us all the way through profitability. And secondly, actually next week, we are opening a joint venture, the facility, I should say. We've started a joint venture with an entity called Marlon Space in the UAE. It's called NovaWurks, and next week we open a 50,000 square foot AI&T facility in Abu Dhabi, which will be one of the largest commercially available AI&T facilities in the Middle East.
Thank you. Since we are in Taiwan, I will say one or two liner in Chinese. 大家好，下午好，各位台湾公司以及代表，我姓赵。我是这个Astranis Space Technology 的亚洲代表，负责商业销售。All right, very good afternoon. I'm Donald Chiu. I think many of the familiar faces here. I lead the Asia Pacific commercial effort for Astranis Space Technologies. Okay. Now, Astranis is pioneering Astranis is pioneering a new class of geocommunication satellites. We currently operate 5 satellites, and we have a backlog of $1 billion revenue. In addition, what is unique in the Astranis model is that we deliver sovereign high-performance satellites. We call it micro-geo satellites. We does not require the customer to build and fund a full-size multi-$100 million satellite programs. So I'm pleased to be here to share what we see the market evolving and how Astranis model helps countries, our partners and customers to respond to new connectivity demand patterns. Thank you.
Hello. My name is Jeff Mackay, and I am the CEO of NovaWurks. We're a Southern California-based satellite manufacturer. Our company has a unique approach to satellite manufacturing. We have a modular bus system, basically a building block system, that is designed to allow the payload is what matters. And you shouldn't have to tailor your payload to a bus. And so the modular building block approach basically says that whatever your payload is, we basically take these building blocks and configure them and build the bus around your payload. So you have the freedom to design for your payload. The building blocks they're all the same, so we can mass produce them. And we're actually at an inflection point right now where we have a contract where we're actually delivering to inventory. So we're looking at the ability to have the satellite bus components available basically on demand, awaiting payloads. Another unique benefit of this approach is that when you start to design your missions and your payloads, you can get a building block from day one and start designing with the bus, not having to wait 18 months and then have the two elements come together and integrate. So we feel that that's a big advantage for our customers. Our customers are primarily government. We find that the commercial space is a little more risk averse and we do things a little bit differently. And so we do have our primary interest is from government customers who are looking at capability and willing to take a little more risk in a new method.
Okay, so let me throw same questions as the last panel, who does what kind of things. Anyone who does geo satellites? To LEO. Okay. Communication satellites, remote sensing, any deep space moon missions, government job. You too, right? Commercial. Okay. So looks like everyone does basically all across the board. Now, Donald, I think Astranis, unlike SIS-12 you heard in the first panel, you're doing some kind of service model. Is that correct understanding?
That's right. Yeah. Yeah, I think it's important. Astranis is vertically integrated. So we design, we build, and we operate. Satellites. As I mentioned, it's called micro-geo satellite. It's patented by Astranis. So these satellites are basically built in Pier 70 in San Francisco. We continue to scale the satellite in productions, and this will actually increase the manufacturing cadence. I think this is exactly the strategy that Astranis has put in place to address one thing that is very critical in the satellite industry today. Is speed is strategic. So this manufacturing cadence that Astranis is doing is really to respond to the market needs in terms of responsiveness. Yeah. So we do almost an end-to-end kind of delivery, meaning we also provide a launch services as well to our partners. So the customer actually do not have to worry, in terms of finding the orbital slot, the baseband or even the RF. So Astranis can fully integrate the entire service and make sure that the customers focus on the core services.
So basically, you get paid after you launch a satellite and provide capacity to the customer. Is that the model?
I would say that it's half right. Definitely, I will be more than happy if a customer is willing to pay a lot more upfront. So Astranis had a very simple financial model. So we had a down payment when we sign a contract, and then the service fee will only start when the satellite is commercially available for service for the customer. So it's basically on a year-to-year, the company will be paying over a contracted period.
Okay, so basically payment will be both before launch and after launch.
That's right.
How does it differ from the traditional innovative incentive type payments?
Right. So very good question, Eddie. Now, so one of the key challenge today for a lot of companies who wants to come into the satellite world, to operate the satellite, one of the biggest hurdle is really having a upfront payment of $400 to $600 million, and not to even to mention that the potential of a 5 to 7 years to get the satellite into the sky. Yeah, so Astranis basically lower the entry barriers, allowing the operators like smaller nations who actually import capacity and they're not sovereign. So Astranis also allowed this capability to let them have a sovereign satellite. Yeah, so I think that is again something that is innovative and unique that Astranis has put in the market.
Mack, you are also in a similar service model, and I don't say similar, but in a service type of the models, like...
That's all we offer, actually, as a service.
Okay. Can you explain a little bit about it?
So for Loft's customers, we actually don't manufacture buses. We are leveraging the good work of many of the folks in this room that are building satellite buses. And what we do is we pre-procure them, we put them on a shelf, and we make them available. And so speed for us is actually just a core tenet of what we do. There's a famous saying by a US Olympian, speed is a commodity. The faster you're going, the safer you are. And that's how we view this at Loft. So for us, we have these satellite buses, we take them off the shelf, we integrate your payload to it. You can be a dedicated system, you can be one of multiple payloads as a ride share, and then we go off to launch. We think about this as, from a service perspective, there is an element of the hardware and the traditional expenditure that you would have that we are recovering through, some portion of our contract being pre-launch. And then there's an operational service level agreement that we have these customers, that our customers are paying as the payloads are accessible to them through their mission duration. So it is It is differentiated from a traditional hardware procurement model where your hardware is fully paid for up front, your launch is fully paid for up front. You are basically 100% cash outlay before you've even turned the satellite on in space.
Okay.
Well,
Jeff, you don't do that kind of service business, I suppose, right? But
no. I mean, our product is a tool, really, and that tool is really designed to kind of free up the imagination for the mission, right? And I think something that's a little different from the way that we do it is when we talk about like inventorying spacecraft elements, you know, it's a flexible approach. I mean, it's really designed so that when you don't know what you need, you still have the components available because you actually take the building blocks and you put them, arrange them in a manner to support that mission. And so I think it's a very unique approach. There was a lot of the panelists mentioned vertical integration. We're a little bit unique in that aspect as well because our building blocks have these unique ISAM interfaces around all of the elements of the blocks. They really are, we call them Slegos, actually, space Legos. And so we actually put them together like Legos. They're structural elements. They have all the elements of a satellite in them. But as far as vertical integration and building all of the elements that go with a spacecraft, our approach is that we can work with multiple vendors and turn their resource elements, you know, like radios and solar arrays and propulsion systems, and make them plug and play. So we kind of have a little different approach to how it works.
I suspect our audience may have a little bit of difficulty to understand what you're talking about, like a unit, right? Can we understand that your unit is basically like a CubeSat type unit?
Well, we get that a lot. So it's not really a CubeSat, right? It's not little tiny modular CubeSats. They're actually quite robust building blocks. They're structural. These ISAM interfaces are extremely robust, and when they connect together, you can create larger structures. We can go anywhere from 100 kilogram satellites up to 1,000 kilogram satellites. And then we actually have some designs building blocks that are even scaled larger. We work with some larger prime partners on taking this modular approach and scaling up for very large structures. So they're not little tiny toys. They are the ability to really take these elements and put them around full-size, very capable satellites.
So actually, one of the keywords that all you three guys are talking about is standardization or modularization, whatever, like that kind of thing. Yet somehow at some point of the satellite manufacturing business, you seem to be standardizing your design or your way to do the business, or your hardware, whatever it is. I suppose that would have to sacrifice customers' specific requirements sometimes. If some customer wants to write a spec in a detail, like line by line, you may or may not be able to own everything, right? As far as you have a standardized product and the way to manufacture business. How would you balance out between your customer management and also your design priority or standardization priority to keep your schedule, costs, and those kind of things, I suppose? Is anyone able to address that?
Well, we've actually had customers inquire because in the building block we have, well, if you assemble a spacecraft and you have 6 or 8 of these, you have a lot of redundancy. And so we've had customers say, well, like an iPhone, it's like, well, I'm never going to use the wide-angle camera, so can you just take that out, right? But I think when you analyze the entire mission costs all the way through, that little bit of extra hardware doesn't merit all the NRE to pull out those individual elements. As far as working with like standardization, one of the things that we focus on is not to try to become a standard, let the industry standards evolve, but have a universal interface or whatever standard does evolve that our building block tools are compatible with them. So, I mean, and there's a lot around like refueling standards, what are those ports going to look like? For us, it really doesn't matter what evolves as the dominant standard, because the way that the ISAM interface that we've developed that's built into the building blocks can accept whatever last mile interface that emerges.
Right. I think for Astranis, I fully agree. Standardizations, will come with certain, compromise. However, for Astranis, it's very unique in the sense that our payload are software-defined payload. So we do allow the flexibilities of, a beam forming, and then certain beam activation as well. So for example, certain customers may require certain beam coverage, over a certain area. We can also design it accordingly. So while I think Elias mentioned about, we have a Block 2 that was launched last year, and then there's a Block 3 that's coming up, which is the fully Ka-band payload. The Block 4 will have a potential of a Ku or Ka payload as well. So that actually allows some flexibility, for customers, to pick up exactly what they need in the market. And I think also it's important to understand that, there will be a different type of vertical market as well. So there will be, enterprise market, there will be government market, there will be the general broadband access as well. So Astranis satellite is also able, to design accordingly, to meet this kind of specification as well. As long as the customer come in early, and work together with our engineering team, we can actually design the satellite, to meet some of their specification as well.
So actually, a little bit ironically saying, Donald, right? A little bit ironically saying about your business model, right? Standardizing a satellite might help you to move the spacecraft on orbit as well if customer fails to pay for the money. Is that also the case? Because you have a digital payload associated with the same frequency band. If you want to, you can move the spacecraft and work from the different orbital slot.
Exactly.
Right.
So, so the current challenge that I think the the geo operator in this room is probably asking the same questions, right? What is there still a business case, viable for the next generation geo satellites? Given the strong competitions from the NGSO, from the MEO, from the LEO. So I think this is exactly where the flexibility comes about for Astranis, where the beams are able to be, the frequency bands are, is really the white hole K band. So if you are a certain market that you put in a lot of investment into one enterprise segment, for example, and then it didn't work out after 2 years, that satellite can be moved to another regions and be able to support, a new kind of market. Because today's markets shift very quickly. Today we may be talking about, mining sector. Tomorrow maybe, it's a wind farm sector. So I think, the market may change very quickly. So Astranis dynamic payload will be allowing our customers to have that kind of flexibility to move their capacities around the region. And in addition, we're also building the next generation satellite. So in the event that the customers decided that they want to upgrade in the middle of the contracted period, they can even we can even replace a satellite with a new generation satellite, which we call it Omega. So that allowed a lot of flexibility while there's certain standardizations.
So if one customer comes to you, Donald, saying that I like your broadband payload design, but I need you to put your 4X band transponders for my military purposes. Would you accept that or no?
I will not give a yes or no answer. I think this is really, we have been getting a lot of requirements. I've been with the company only just 3 months, but in the last 3 months, I've been, on the road almost every week. Now, so I have been getting a lot of requirements. Are you able to do X-band? Are you able to do, QB band, and so on and so forth. Yes, I think that is something that we will take in all this feedback. And as I mentioned, there's a Block 4 that's coming, there's a Block 5 that's coming. We definitely can consider looking at all these other payloads as well.
Okay. I have been actually struggling by myself, quite frankly speaking, which is better for me to do the manufacturing satellites. Do I increase the percentage of self-production of hardware, or do I go to outsource the hardware to other companies to have a subcontracts with a firm fixed price so that I can cut down all the risks and schedule to be clean compared to internal? I suppose many startup companies are more tended to build hardware by themselves. What's your case? And do you have any rationale doing that? That's my next question.
So that's a great question that you are wrestling with. And Loft has taken the position of not building its own hardware and procuring hardware and having those types of relationships with subcontractors. Part of our value proposition is being bus agnostic. We can pick one off the shelf. But what that does is that it removes and obfuscates the challenge of timeline for our customers. So today you can call a bus manufacturer and they'll tell you, we'll deliver it to you in 18 months. Great, that's probably more like 24. Okay, then you deliver your payload, you have AI&T. Don't forget environmental testing. SpaceX now wants 100 days before launch, et cetera, et cetera, et cetera. Well, you're at 3 years. That in today's pace of business and with concepts like Golden Dome and sovereign systems and people wanting procurement and systems and satellites in 12 months, that does not work. So, yep.
Let's go to 30 seconds each. Sorry, I have to touch on some questions later, but please go ahead.
Sorry, I got lost in the question.
Yeah, actually, in-house production or outsourcing?
Yeah, so our core product, we build ourselves. We do that all in-house. So the core building block, that tool, is all us. But like I mentioned before, all of the other elements that we would put together if we were doing a full integration on a satellite, we would source them from the best solutions for the mission. That's our focus. Whatever component is the best way to solve that mission requirement, that's where we want to work with. And so, kind of by our nature as a tool, we wouldn't want to build too many things ourselves. I mean, and I have a little bit of experience in manufacturing. It's difficult to become an expert in everything. And by the time you do, maybe what you've become an expert in, maybe it's moved on and is no longer relevant. So it's hard to be the best at everything.
Okay.
I'll take the questions on that as well. I mentioned that Astranis basically built our satellites all in-house. What is interesting is that like I mentioned, I was only 3 months with the companies. I went to the headquarters. I am really shocked in the sense that a lot of very young we call it Y Combinators. I think the satellite industry has really evolved. There's a lot of younger generations are coming to the industries. Now, I think that having all these really experts in the field, so-called subject matters, building the different parts of the components, and then build it in-house, that actually allows you to ensure that the whole delivery of the satellite is a lot smoother, rather than having a outsource where certain part of the components you may not have the ability to control that. So I think, in my opinion, Astranis definitely is looking at more of an in-house. Yeah.
Okay. We have 2 minutes. I don't know. Let's go to the first question. For Astranis, what is the launch status of your satellite for Changhua?
Short answer, 2026.
Let's go to the last one first. What's the average lead time for your satellite? Just one word each. About how many years, how many months, whatever it is.
Order to launch, 6 months.
From order to launch.
Yeah, for a communication payload, like what Astranis is putting on, we're cutting down from the traditional satellite of 5 to 7 years to less than 24 months.
And our components, the on-the-shelf elements, they would be available immediately. But again, to your point, we would be reliant on subcomponent suppliers, and we typically see some of those longer lead items can be 12 months.
Okay. Only one person to answer the second question. In a market shaped by constellation and sovereign program, what will define competitiveness in satellite manufacturing over the next decade? Cost, speed, or innovation? Anyone can take it? One person.
Speed. I think I mentioned before, speed is strategic. Market shift, funding cycles narrows. The demand for capacity to arrive is now in months and not years. So I think speed is critical.
Okay. I think that concludes the panel. Thank you very much, and let's give a hand to them. Thank you.
Thank you all.